As a short demonstration of how shielding materials and stuff look like, so today I've set up also a document camera here, and I think I can switch over to this. So here's my coffee for today. And with this document camera, I can of course also show various shielding materials. I think that I've shown before, but this one is something that I've not shown before. It's from a German company, Würth Electronic, and as you can see, it's some do-it-yourself shielding cabinet kit. So the instructions are here. You get a piece of metal and you can cut it with scissors into the pattern that you would like to have, and then you can fold it and bend it also with sharp edges and corners. And you can use it to shield something, for example, on the printed circuit board. Then of course you somehow need to also solder it to the printed circuit board, or you can use it to shield something else. And it's, if I take it outside this enclosure here, then you can see that it looks like this. So it's a shiny piece of metal. I think it's made out of steel. So what we discussed is that the conductivity of steel is not as good as of aluminum or copper, but there is some permeability. And so I think the size, as you can see here, of one of these squares is approximately 0.5 centimeters or 5 millimeters. And then you can cut it and bend it into this shape. So I think this is also something nice to do shielding. And the other samples that I had shown the last time was from this Feuerherdt company. This is also a German company, and these are these finger stocks or spring contacts for shielding doors. And just the noise is nice. And so there are various parts here, and this is really, even if it looks like copper and it is somehow the surface is copper, it's really a spring material. So yeah, just by how it bounces back from the table, you can see that it's kind of springy. And yeah, there are different types. And this is also quite interesting. I think this almost looks like something from medical engineering, like a stent that you put in some artery somewhere. But this is also metal, also conductive, to have a good contact somewhere, let's say where some shielding door closes, where you would like to have some contact. And this is the same but made from rubber material, so this will also seal some door, let's say, against water or air pressure, and at the same time do some mechanical contact. And you can see they are in various sizes and different materials and different mounting options and so on. So this was from Feuerherdt, and just let's move this to the side. I think this is also something that I've shown before from 3M, the company you know from gluing tape. And they have different materials also for shielding. I think this is something very thin. I've not studied the data sheets, but this is some, I think, also ferrite material. This is the classical conducting copper tape. This is also, I think, something that works more for magnetic shielding. I mean, here would be the QR codes to check the relevant websites. And yeah, so just lots of different samples with all the part numbers printed on it. But I have no clue. I have not read before what the details between, or what the difference between them are. But this is also what could be used on circuit board level. And then from this nice company, or Holland Shielding, This is, I think, also a sample kit that I've shown before, but just in the larger camera, not on this document camera. And so the interesting piece here maybe is this one, because this is something that could be used to shield a ventilation hole. And this is called, as you can see, a honeycomb mesh, because it little bit looks like a honeycomb from a bee. So the idea there is that you have many parallel waveguides, and they are all small in comparison with the wavelengths, so they are all under cutoff frequency and will attenuate and will damp. And so air can get through, but electromagnetic fields, at least if the wavelength is much larger than the size of these holes, cannot. And this is also copper material. This is some conducting copper tape. This is also some wire mesh, very thin, or some conductive fabric that can also be glued to something. I think this is aluminum that can be glued to something. And these are also seals for some enclosure. So there's always some foam part in the center that is elastic, and then you have some conductive cover on the outside. And so this is a little thicker material that can be used for this, and a very thin one, and a less flexible and a more flexible one. And so they will all have their advantages and disadvantages on, let's say, what is the contact force that you need, and what will be the resulting shielding efficiency and so on. And the last piece that did not came out here is something like a spring contact, but also made out of this metallized textile with some foam in the center. But you can see that it's really nicely elastic, and will give a nice contact force all the time. Okay, so this was from Holland Shielding, and the last sample kits are from, I think, this is a Japanese company. You can also see I got this from some conference, but they also have offices in the United States and in Malaysia and so on. And they have, maybe I think I have a second box where it's easier to get this out. They also have seal materials like this. So you have some, let's say, your shielding enclosure, and you want to connect or contact a shielding door, and you need to have a seal. So this is also rubber material that is then metallized. And so they come in different sizes and different contact materials and so on. So this is something that they produce. I think this is the same here, that is now already glued to this aluminum plate. I think this is not from Nolato. This is some other board level shield on a printed circuit board that I might have shown before. It's kind of interesting how the camera has some problems with the brightness because these parts are reflecting that much. And this is also kind of interesting, because you can see here these are silicon is a silicon material, so also some kind of rubber material for gaskets. So for feed-throughs, you have some shielding enclosure, and somewhere you want to get cables in and out, or you, as said, want to connect a board level shield. And so how can you have a shielded cable feed through? And then of course the shield of the cable somehow needs to be connected to this feed through. So this is for cable, this is for cable, this is also for cables, and I think this is also something to connect another piece of material, the same as here. I'm not an expert in these components, and I think the important thing then at the end is that this, wherever you mount this to, this is just a plastic, but this then of course should be also conductive, or should be also some kind of metal, otherwise does not make sense, right? Because you need to have metal all around. So This was from this company, and the other samples that I think I've also shown before were these metallized textiles. So this is the more coarse material. I think these fibers here are directly made out of metal. And so it's not a metallized plastic fiber, let's say. So this would be also very solid and heat resistant, but not super flexible, and maybe you can also not bend it 100,000 times because the metal fiber will break, but mine's still not too bad. And the other way to produce such shielding textile would be this, what I've also shown before, this type of material. So this is very thin, very flexible, and I think these are polyamide or some plastic fibers that then have been metallized on the surface. And so this would be also not super heat resistant because it's plastic, but it's very thin, very flexible, very light, and the mesh is of course very dense. So the shielding efficiency should be quite good, but one problem that you can see is in one of these parts. What was it here? Where was it? Here it is. So here you can see if it's exposed to heat or if it's exposed to sunlight, ultraviolet light, then the material might degrade. And I'm not sure if the shielding efficiency would still be good or bad, or if it's also degraded, because at least there's some optical effect. I don't know if the conductivity will, for example, decrease due to this. Yeah, but you can somehow see here on this piece, which the way how it was folded, how it was exposed to sunlight or not. Almost looks like a batik t-shirt from the 1980s or 1990s. So quite interesting overview over some shielding materials once again.